Okay, so this lesson is on the algebra review lesson of how to solve a system of equations using substitution. There are lots of different ways to solve systems of equations. A system just infers that it's more than one equation with the same set of variables. For our purposes in this class, we will have two equations that have two variables. So there'll be an x and a y variable between the two equations. But it can be any set of equations with any set of variables. There are three ways that you can have a solution for a system of equations. Since we're only doing two equations with two variables, I gave you examples of those. So in solution A here, you can see that if the two lines intersect, that means that there is one solution. The point where they intersect is considered the solution to the systems. In B, you can see that the lines are parallel, and since that means they will never intersect, that means that there will be no solution to the system of equations. And C, if the lines lie one on top of the other, then that means that there would be an infinite set of solutions. As the lines are exactly the same, there'd be an infinite number of points where they cross. We are going to focus strictly on this relationship here, because for geometry, we need to be able to find our system. So the way that you can solve a system using substitution, now you can solve using elimination or graphing or all kinds of things, but we are going to strictly work with substitution in this lesson. There are 4 steps. Notice that both of our examples have two equations and they both have two variables. So step 1 would be to look at your two equations and to find which one of the 4 variables, either one of the x's or one of the y's, to get that variable isolated, to get it by itself on one side of the equal sign. Now sometimes you're given that, okay? For example, in example 1, this y is already by itself on the left-hand side of the equation. So for this system, you would be able to skip step 1 because y is already alone. In example 2, we will have to solve for one of our variables. So for example 1, we get to skip over step 1, we get to go on to step 2. Step 2 says write the other equation, okay? So not the one that is solved for a variable, but the other equation. So we are going to do that. I am going to switch over to our writing tool. Okay, and so I'm going to take this equation, but instead of writing out the whole equation, anywhere there's this variable, I'm going to replace that variable with a set of parentheses. So I'm going to write this equation. So I'm going to write 2x plus equals 16, but instead of the y here, I'm going to set a set of parentheses. The reason I'm going to do that is because that's going to be my clue that that's where I'm going to do the substituting. Okay. So I did that now. Step 3 says plug the first equation into the second equation. So that means in the parentheses, instead of my y value, I'm going to put what y was equal to. So I'm taking out the y value and I'm putting in the 4x plus 10 because that's what y was equal to in the other equation. What that does for me now is it gives me one equation with only one variable. That makes it solvable. Okay, so now I do my algebra skills. If there's anything directly outside the parentheses that I have to distribute, I would do that first. But in this case, there is nothing directly outside the parentheses, so I can just start putting my like terms together. So 2x plus 4x is 6x, plus 10 equals 16. And then I would subtract my 10, so I would get 6x equals 6, and then I would divide by 6, and x is 1. Okay, so my solution, the x coordinate will be a 1. I still need to find my y coordinate. I don't know what y is yet, but because now I know what x is, I can bring that back up and plug it in. And it doesn't matter which equation I plug it into. I can plug it into either one. But since this one's already solved for y, this one would be the easier one to put it in. Okay, so I'm going to take 1 and I'm going to plug it in for x. So instead of 4 times x, I'll have 4 times 1, which is 4, plus 10 is 14. So my y coordinate would be 14. So my solution to this system would be when x is 1 and y is 14. So I would write that as a point. That would be the point where if I graphed those, the point 1, 14 would be where they crossed each other. All right, in example 2, we have to start back at step 1 here because none of the 4 variables are all by themselves. Okay, for this one, I will just bring the y over, so I will subtract it over to this side to get the x alone. So it'll be x equals 3 minus y. And then I go on to step 2 where I write the other equation. So I'm going to write this equation, but anywhere there's an x, I'm going to replace that with parentheses. So I'm going to go 2 parentheses plus 4y equals 12. So notice I wrote this whole equation, but I put parentheses where the x was because that's where I'm going to do my substituting. So step 3 now is to actually do the substituting and solve. So instead of x, I'm going to put 3 minus y in here. That's my actual substitution. And then this one does have something directly outside the parentheses, so I'm going to have to distribute. So 2 times 3 is 6. 2 times negative y is negative 2y. And then plus 4y equals 12. Notice that still turned into one equation with one variable. That's what makes it solvable. That's why we do the substitution. So now I will still put my like terms together. Negative 2y and positive 4y gives me a positive 2y. So I have 6 plus 2y equals 12. I will subtract my 6 and get 2y equals 6. And then I will divide by 2 and y equals 3. Okay, so now the y coordinate of my solution will be 3, but now I'm going to take that 3 and I'm going to plug it back in. Again, you can plug it into the original either one equation, it makes no difference. So I'm going to plug the y equals 3 in here, so it becomes 3 minus 3. 3 minus 3 is 0, so x equals 0 is my x coordinate of my solution. So my solution will be where x is 0 and y is 3. That's how you solve a system of equations using substitution. And that's the end of the lesson.